Okay, John, I'm going to uncover this part of the fiber optic detector system. And right there is a laser diode that produces a blue laser beam. It's 10 milliwatts. The reason why I have it covered with this styrofoam cup is to get rid of airflow currents that might be causing it to fluctuate slightly. This is a regulator, and it's mounted right on the diode, next to the diode. Okay, so that laser diode is coupled optically into a fiber cable similar to this tube, which is inside this vacuum system. And this is the hose that pumps the vacuum out of this system. Now this system can be filled the same way with liquid nitrogen if I want to cool it down, but right now I'm not doing that. Okay, on the other side is a photomultiplier, and this is the voltage for the photomultiplier. It's set at 800 volts. That gives me about 1,000,000 times magnification. This photomultiplier converts the light coming from the photodiode into electricity. Then the signal comes out and goes over here to this system here, which is a phase lock loop amplifier and a filter system. Then I've got coming over here is a signal. Now this is the noise level because I've got the laser diode off and everything else on. This one's set at 2 milliseconds. And this scope over here is set at 20 milliseconds. And this one up here is set up at 1 second. And you can see, I'll try to block out some of this is the noise level that I've got over 1 second. Okay? So we've got 3 different scopes looking at 3 different frequencies, or bands of frequencies. Okay. Okay, down below this table is the laser diode power supply. I'm going to turn it on. The table has 4 rubber tires. And then the table is also made out of granite, weighs about 300 pounds. And I've got some more isolation here, and then I've got the vacuum system on top of that isolates the fiber. Basically, I suck the air out of there so I don't have any thermals. Okay. Now, when we come back and look, you can see how much signal we're getting on top of the noise level. There's a good example over 1 second. Let me block this all out. You got a fairly big signal there, John. Now that's coming from the modes of the laser going down the fiber, the optical modes. The electromagnetic fields in the fiber are changing due to change in the fiber. Now what's that changed by? Could be gravity, it could be some fluctuations and some vibrations, but I've checked out most of it, so I don't really have a clue until I build 2 more systems identical and compare them. I've already checked the light output of the diode, and that's not fluctuating, so that is just actual fluctuations due to the fiber stretching due to some reason, either thermal, mechanical, or actually maybe gravity waves. Okay, that's it, John. Speak to you later.